Welcome back, my dear students. In the last session, we have learned part 2 of chapter number 6, square and square roots. Today, let us learn part 3 of chapter number 6, finding square roots. There are three methods to find out square roots. The first one is repeated subtraction method, second one is prime factorization method, the third one is division method. Now, let us discuss about finding square root by repeated subtraction method, this first one. Suppose one question comes, find the square roots of 49 by repeated subtraction methods. Suppose a question comes like that. Now in the solution we can do this type of question like that. We have take this 49. Now we are going to subtract odd numbers. The first odd number is 1, so minus 1. 49 minus 1 is 48. Next, take this 48. After 1, the next odd number is 3. 48 minus 3 is 45. 45 minus, after 3, next odd number is 5. 45 minus 5 is 40. Next is 45 minus, after 5, next odd number is 7. If we subtract, then we are getting 33. Then 33 minus, after 7, the next odd number is 9. 33 minus 9 is 24. Next is 24 minus, after 9, next odd number is 11. If we subtract, we are getting 13. Then 13 minus, after this number 11, next odd number is 13. 13 minus 13 is 0. We get this number 0 after subtracting first 7 odd numbers. Therefore, this is a symbol of square root. Square root of 49 is number of times of subtraction, that is 7. So here it is over. I hope you can understand this. Sige yani ko kaisu yam lubna te. Ngasai gi piramiba number dagi odd number singsi mathang oina minus orani adugi du 0 tabawo minus orani aduga kara khanna akoina minus togi haisi yengani 1 times 2 times 3 times 4 times 5 times 6 times 7 times minus tore adu tardi therefore square root of the given number is 49 is since we have subtracted 7 times, that number 7 is the answer. Sida loire si yarni ko adudi simuk torsi number 2 gise prime factorization method. Prime factorization method ji sinarga square root ka maina potokata ki simuk torsi. Now number 2, finding square root by prime factorization method. Now one question comes like that. Find the square root of 2304 by prime factorization method. Prime factorization methods. Now let's try to solve this question. Solution. Here the question says that to find out the square root of 2304 by prime factorization method. First, let's write we know, then write the given number 2304, and we have to use prime factorization method. So this 2304, we have to find out its prime factor. 2304. This number is n by 4, so we can divide by 2. 2 1 time is 2, 2 1 time is 2, 2 5 time is 10, 2 2 are 4. Again divide by 2. 2 5 time is 10, 2 7 are 14, 2 6 are 12. Again divide by 2. 2 2 are 4, 2 8 are 16, 2 8 are 16. Again divide by 2. 2 1 time is 2, 2 4 time is 8, 2 4 time is. Again let us divide by 2. 2 7 are 14, 2 2 are 4. Again let's divide by 2. 2 3 are 6, 2 6 are 12. Again divided by 2. 2 18 times is 36, 2 9 times is 18, divide by 3 times. Here finding the factors are over, so we are getting here 2 1 2 3 4 5 6 7 8. So 2 is 8 times. After that 2 3s 3 3. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7. 2 is 8 times. Then 3 2 times. 3 3. So let's group into pair. 2 2 making one pair. 2 2 making one pair. 2 2 one pair. 2 2 one pair. 3 3 pair. Therefore, square root of this number 2304 is equal to, if we want to find out the square root of this number from this two pair, 1 2 we'll get. From this pair we will get 1 2. From this pair another 2. From this pair another 2. From this 3 pair another 3. And let us multiply this. 2 2 are 4, 4 2 are 8. 3 times is 6. 8 6 times is 48. We are getting 48. So the square root of 2304 is 48. And this method is called finding square root by prime factorization method. So this method here we are using is prime factorization method. And this third method of finding square root, let us do this afterwards. Now let us learn this first method and the second method. And this first method and the second method, these two methods we are going to apply in the next exercise. Now let's start exercise 6.3. Question number 1. What could be the possible ones digit of the square root of the following numbers? Now let's try Roman number 1, 9801. Here the question says that if we try to find out the square root of 9801, what could be the possible ones place digit? Now solution. We know if 1 is multiplied by 1, we will get 1. And if 9 is multiplied by 9, there is 81. Here we see that here one's place digit is 1, here one's place digit is also 1. Therefore, the possible ones digits of the square roots of this given number 9801 is, that may be this number 1 or this number 9. So 1 or 9. 1 and 9 is the answer. If we try to find a square root of 9801, then the possible ones place digit may be 1 or 9, and this is the answer. Sigisi yarniko sigise. Dimathang amutoge. Now Roman number 2. $99,856. Now let's try to solve this. Solution. This Roman number 2 is also same as Roman number 1. We know if 4 is multiplied by 4, then we will get 16. And if 6 is multiplied by 6, that is also 36. Here 1's place digit is 6, and here also 1's place digit is 6. So if we try to find out square root of 99,856, the 1's place digit may be this number 4 or maybe this number 6, and 4 and 6 is the answer. Therefore, the possible ones digit of the square root of this number 99,856 is 4 or 6. 4 or 6, and this is the answer. Understand or not? This is same as Roman number 1. Next is Roman number 3. Here in this Roman number 3, the 1's place digit is 1. So if we try to find out square root of this number, the answer will be 1 or 9, because 1 times 1 is 1 and 9 times 9 is 81. Now Roman number 4. Here the 1's place digit is 5, and we know that 5 times 5 is 25. So if we try to find out square root of this number, the 1's place digit will be 5. For this Roman number 4, only one digit will come, that is 5. So 3 and 4 you try as homework at home. Now let's try this question number 2. Without doing any calculation, find the numbers which are surely not perfect square. Roman number 1, 153. Roman number 2, 257. Roman number 3, 408. Roman number 4, 441. Here the question says that without doing any calculation, we have to find out these given numbers which are the perfect square and which are not the perfect square. So to try this question, let us remind these properties of square number. First point, if a number ends in 0, 1, 4, 5, 6 and 9, then it must be a square number. Then the second one, we have to use this. If a number ends in 2, 3, 7 and 8, not the numbers, once again, not the digit. If a number ends in 2, 3, 7 and 8, then it is not a square number. So here this 82 is n in 2, so this is not a perfect square. Here this number is n with number 3, so this is also not a perfect square. So if a number is n in 2, 3, 7 and 8, those numbers are not square number. Okay, let's use this. Square number and perfect square are same. So here Roman 1 then 53. This number is n with 3, so this is not a perfect square. This 257 is n with number 7, so this is not a perfect square. This number is n with number 8, so this is not a perfect square, but this is n with number 1, so this may be a perfect square. So the numbers which is surely not a perfect square are Roman number 1, Roman number 2, and Roman number 3. Because Roman number 1 is n in 3, Roman number 2 is n in 7, and Roman number 3 is n in 8. Okay, now let's write the solution. Now solution. The numbers which are surely not perfect squares are Roman number 1, this 153, Roman number 2, 257, and Roman number 3, 408. Because the numbers and with 3, 7, and 8 respectively. Here this question is of understand or not. Now let's try question number 3. Now question number 3. Find the square root of 100 and 169 by the method of repeated subtraction. In this repeated subtraction, we are going to subtract odd numbers successively. Now solution. We know here the given number is 100. The first odd number is 1. Then 99 is getting 99 minus the second odd number is 3. Then 96 is getting. Then this number 96 minus next odd number is 5. 91. 91 minus next odd number is 7. 60. 84. So 84. 84 minus next odd number is 9. 75. Next is 75 minus next odd number is 11. 64 is getting. Then 64 minus next odd number is 13. If we subtract, we are getting 51. Then 51 minus next odd number is 15. If we subtract, we are getting 36. 36 minus, after 15, next odd number is 17. 36 minus 17 is 19. Then 19 minus 19, and we are getting 0. Let us see how many times we are subtracting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are subtracting this number 10 times. After that, we are getting 0. We get 0 after subtracting first 10 odd numbers. So here we are subtracting first 10 odd numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first 10 odd numbers. Therefore, square root of 100 is equal to this 10, and this is the answer. Understand or not? This is not so difficult, so I hope you can understand that. Next is 169. This question is same as this first one, so if you can understand this, you can solve this question. So this 169 you practice. Then now let's try question number 4. Question number 4. Now question number 4. Find the square root of the following numbers by the prime factorization method. Now we have to use prime factorization method, and we have to find out the square root of Roman number 1, 729. Okay, now let's try this. We know 729 is equal to, here we are going to use prime factorization method. So first we have to find out the prime factor of 729. 729, let's find out the factors of 729. 729 we can divide by 3, so let's divide by 3. 3 2 times is 6, 7, 3 4 times is 12, 3 2 times is 9. Again let's divide by 3. 3 8 times is 24, 3 1 times is 3. Again divide by 3. 3 2 times is 6, 7, 8, 3 7 times is 21. Again by 3. 3 9 times is 27. Divide by 3. 3 times here. Finding the factors are over. 1 2 3 4 5 6. 3 6 times. 1 2 3 4 5 and 6. Now let's pair the equal factors. 3 3 this. Therefore, square root of this 7 to 9. If we try to find out this, square root of 729 from this 3 pair, 1 3. From this 3 pair, another 3. From this 3 pair, another 3. Now 3 into 3 is 9. 9 into 3 is 27. So we are getting 27. Hence, the square root of 729 is equal to 27, and this is the answer. Sige yarne ko ba dum tai ko adudi mathang gi toge. Roman number 2 is 400. Roman number 3 is 1764. Roman number 2 and 3 are same, so you can try this Roman number 2 and 3, and let me select the bigger number. So Roman number 4 also you try. Now let's try Roman number 5. Let me do this Roman number 5. Now Roman number 5 solution. This question is also same as Roman number 1. We know, write the given number 7,744. First, let's find out the prime factor of 7,744. 7,744. Here the last digit is 4, so we can divide by 2. So let us divide by 2. 2 3 times is 6. 7 to 8 times is 16. 17 to 7 times is 14. 2 2 are 4. We are getting this. Again divide by 2. 2 1 times is 2. 2 9 times is 18. 2 3 are 6. 2 6 are 12. This is getting. Again divide by 2. 2 9 times is 18, 19. 2 6 are 12. 2 8 are 16. We are getting this. Again let's divide by 2. 2 4 times is 8. Next is 16. 2 8 times is 16. 2 4 times is 8. Again let us divide by 2. 2 2 are 4. 2 4 times is 8. 2 2 are 4. Again let us divide by 2. 2 1 times is 2. 2 2 are 4. 2 1 times is 2. 121 we can divide by 11. Then 11 times. 1 2 3 4 5. 1 2 3 4 5 6. 2 is 6 times. 1 2 3 4 5 6. 1 2 3 4 5 6. After this 11 into 11. Now pair of the numbers. These are pair, these are pair, these are pair, these are pair. Therefore square root of this number 7744. If we are taking square root from this 2 pair, 1 2. From this 2 pair another 2. From this 2 pair another 2. From this 11 pair 1 11. Now let us multiply this. 2 to our 4, 4 to our 8, 8 into 11 is 88. 88 is the answer. Hence, the square roots of this number 7744 is equal to this number 88. Here this question is over. Understand or not? Now let us select question once again. Okay, next question. Roman number 6, 7, 8. Let's do 8. Okay. And remaining question you need to do practice at home. Okay, so now let's do this Roman number 8. Now Roman number 8, 9216. Now solution. We know, write the given number 9216. Let us find out the prime factor of 9216. 9216. Here unit place digit is 6, so we can divide by 2. 2 4 times is 8. 2 6 times is 12. Next is 0. 2 8 times is 16. Again divide by 2. 2 2 times is 4. 2 3 are 6. 2 4 times is 8. So again divide by 2. Divide by 2. 2 1 times is 2. 2 1 times is 2. 2 5 times is 10. 2 2 are 4. Again let us divide by 2. 2 5 times is 10. 2 7 times is 14. 2 6 are 12. Again let us divide by 2. 2 2 are 4. 2 8 are 16. 2 8 are 16. Again let us divide by 2. 2 1 times is 2. 2 4 times is 8. 2 4 times is 8. Again let us divide by 2. 2 7 are 14. 2 2 are 4. Again divide by 2. 2 3 are 6. 2 6 are 12. Next is divide by 2. 18 divide by 2. 9 times divide by 3. 3 times. Here it is over. Let's count the number of 2's. 1 2 3 4 5 6 7 8 9 10. 2 is 10 times. 1 2 3 4 5 6 7 8 9 and 10. Then 3 2 times. 3 another 3. Let us pair of the equal factor. This is pair, this pair, this pair, this pair, pair, 3 pair. Therefore square root of 9216 is equal to, if we are taking square root from this 2 pair, 1 2, from this another 2, from this another 2, from this 2 pair another 2, from this pair another 2, from this 3 pair another 3. Now let's multiply these numbers. 2 to our 4, 4 to our 8, 8 to our 16, 16 into 2 is 32, 32 into 3 is 96. So 96 is getting. Hence, the square root of 9216 is what we are getting 96. Sige, yarni ko, bhab tarni ko. We have finished Roman number 8. Roman number 9 and 10, let's not waste our time. So Roman number 9 and Roman number 10, you practice at home. Now let's try this question number 5. Let's study the question once. For each of the following numbers, find the smallest whole number by which it should be multiplied so as to get a perfect square number. Also find the square root of the square number so obtain. Roman number 1, 252 is given. Here the question says that in this given number, how much the smallest number will multiply this number so that the answer is a perfect square. And in the second question, it is asking that here it is asking that for that perfect square number so obtain, you need to find out its square root. So now let's write this question number 5, Roman number 1. Now solution. Here the given number is 252. We know 252. For this 252, we have to find out its prime numbers, prime factors. 252 is divisible by 2, so let's divide by 2. 2 1 time is 2, 2 2 are 4, 2 1 time is 2. And this number 121 we can divide by 11, then we are getting 11. So let's write these factors. 2 into 11 into 11. Here if we try to pair of the equal factors, 11 are in pair, but this 2 is not in pair. We see that the prime factor number 2 is unpair. Therefore, the smallest number by which this number 252 should be multiplied to make it a perfect square is this number 2. Now 252 will be multiplied by this 2. If we multiply 2 times 2 is 4, 2 5 times is 10, 4 5, we are getting 504. Here there is one mistake, so let me correct it. When we try to find out the factor of 252, here I make a mistake, so let's try and find out the factors once again. 252 divided by 2. 2 1 time is 2, 2 time is 2 is 4, next is 12, 2 6 time is 12. Then divide by 2, 2 6 are 12, 2 3 are 6. Then by 3, 3 2 times, 3 1 times, by 3, 3 7 times. 2 2 times, 3 2 times, then 7. So let me correct this. So the factors are 2 into 2 into 3 into 3 into 7. So 2 into 2 into 3 into 3 into 7. Now 2 and 2 are in pair, 3 and 3 are in pair. We see that the prime factor, this number 7, is not in pair. So 7 is unpaired. Therefore, the smallest number by which 252, this number, should be multiplied to make it a perfect square is this number 7. Then now writing this 252 into multiplying by 7. 7 2 times is 14, 1 carry, 7 5 35, 36, 3 carry, 7 2 are 14, 15, 16, 17. So we are getting 1764. And if we try to find out the factors of 1764, now the factors will be 2 into 2 into 3 into 3 into 7 into 7. In this factor, we are going to multiply another 7. Then this number is getting, now 7 is in pair, 3 is in pair, and again number 7 is in pair. Next is we have to try to find a square root of this number. Therefore, square root of 1764 is equal to, from this 2 pair 1 2, from this 3 pair 1 3, from this 7 pair 1 7. 2, 3 are 6, 6, 7 are 42. So 42 is the answer. So this is the answer here. This question is over. Next is Roman number 2 and Roman number 3. These questions are same. So you practice this Roman number 2 and 3. Now let's do this Roman number 4. 2028. Now Roman number 4. Solution. This question is also same as Roman number 1. We know, write this number 2028. Let's find out the vectors of 2028. 2028. The unit place is 8, so we can divide by 2. 2 1 time is 2, 0, 2 1 time is 2, 2 4 time is 8. And then divide by 2, 2 5 time is 10, next is 0, 2 7 are 14. Let us divide by 3. 3 1 time is 3, 4 5, 3 6 time is 18, 19, 20, 3 9 time is 27. 1 6 9 we can divide by 13, then we will get 13. So the factors are these factors. Let's write here 2 into 2 into 3 into 13 into 13. Here these 2 are in pair, these 13 are in pair, and this 3 is unpair. We know that this number 3 is unpair. 3 is unpair. Therefore, the smallest number by which this number 2028 should be multiply to make it a perfect square is this number 3. Now write this 2028. Let us multiply by 3. So if we multiply 3 are 24 to carry 3 2 times is 6 7 8, 3 0 times is 0, 3 2 times is 6. We are getting this. And this number again, if we want to write into factors, then 2 into 2 into 3 into 3 into 13 into 13, we will get this. 3 is pair, 2 is pair, 3 is pair, 13 is pair. Therefore, square root of this number 6084 is equal to, from this 2 pair 1 2, from this 3 pair 1 3, from this 13 pair 1 13. 2 3 times is 6, 6 3 times is 18, 1 carries on 7, 78 is getting. So this is the answer. This is not so difficult. I hope that you can understand that. Roman number 5 and 6 are same, so you practice 5 and 6. Now question number 6. Let's study this question number 6 once. For each of the following numbers, find the smallest whole number by which it should be divided so as to get a perfect square. Also find the square root of the square number so obtained. This question number 6 is almost same as question number 5. In this question number 5, this is multiply, and in question number 6, and this is divided. So let's try this Roman number 1. And the question is like that. In this given number 252, by which smallest number we have to divide this to 52 so that the quotient we obtain should be a perfect square. So to find out the number, first we have to find the factors of 252. Then after getting the prime factors, we have to group into pairs of equal factors. Then we have to find the prime number which is unpaired. Question number 6, Roman number 1. Now solution. We know, write down 252. Let's find out its factor. 252 divide by 2. 2 1 time is 2. 2 2 are 4. 2 6 are 12. Again divide by 2. 2 6 are 12. 2 3 are 6. Divide by 3. 3 2 times is 6. 3 1 time is 3. Again divide by 3 7 times. So factors are this: 2 into 2 into 3 into 3 into 7. 2 is paired, 3 is paired, and 7 is unpaired. We know that this number 7 is unpaired. Therefore, the smallest number by which 252 should be divided to make it a perfect square is this number 7. Now 252 is should be divided by this number 7. Then is equal to sign. Then 7 will divide 252. 7 3 are 21. Then 42. 7 6 times is 42. We are getting 36. So 36. And the factors of 36 are 2 into 2 into 3 into 3. Therefore, square root of this 36 is equal to 2 is pair, 3 is pair. From this 2 pair, 1 2. From this 3 pair, 1 3. 2 3 times is 6. So 6 is the answer. Here this question is over. I hope that you can understand that. Roman number 2, 3, 4, 5, 6 are same. So let's not waste our time. You practice this Roman number 2, 3, 4, 5 and 6. And if you are not able to solve it, you can ask in the Google Meet class. Now let's try this question number 7. Let us study this question. The student of class 8 of a school donated rupees 2,401 in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. Here the question says that for Prime Minister's National Relief Fund, the students of class 8 of a school donated money, and the total amount of money they are collected is rupees 2,401. Each student donated as many rupees as the number of students in the class. Then means if in the class, if there are 30 students, then each student donated rupees 30. And suppose if the number of students in the class is 50, then each student of the class donated rupees 50. if they are doing like that, and if the total amount is rupees 2,401, then we have to find out the number of students in the class. So to solve this question, we are going to find out square root of this number, that means 2,401, and if we find out the square root of 2,401, that will be the number of students in the class. So let us try to solve this question number 7. Question number 7, solution here. The total money donated by the students and that is given as rupees 2,401. In the question it is given that each student donated as many rupees as the number of students in the class. Therefore, the number of students in the class is equal to, we have to find the square root of this number. 2401 is equal to square root of, let's find out the factors of 2401. Let us divide by 7. 7 3 are 21, 22, 23, 24. 7 4 are 28, 29, 30. 7 3 are 21. Again, let us divide by 7. 7 4 are 28. 7 9 are 63. Again, divided by 7. 7 7 times 49. So the factors are 7 7 7 7. 7 into 7 into 7 into 7. This 7 and 7 are in pair. This 7 and 7 also are in pair. If we try to find a square root of this number, from this 7 pair, 1 7. From this 7 pair, another 7. 7 7 are 49. So the number of students in the class will be 49, and this is the answer. Understand or not? I hope you can understand that. Question number 8 is same, so you try this question. Now let's try question number 9. Find the smallest square number that is divisible by each of the number 4, 9, and 10. Now in this question number 9, we are going to find out the smallest square number that is divisible by 4, 9, and 10. Okay, now let's try this question number 9. Question number 9, solution. We know that LCM is the smallest number divisible by all its factors. Now let's find out LCM of, LCM of 4, 9, and 10 is equal to, let us calculate LCM. 4, 9, and 10. Dividing by 2, 2 2 are 4, 9 to 5 times 10. And then 5 2 times is 10, 180 is getting. LCM is 180. So we have calculated LCM, that is 180. Now let's find out the factors of 180. Divide by 2, 2 9 times is 18, 0. Divide by 2, 45. Divide by 3, 3 1 times, 3 5 times, 3 5 times, 2 2, 3 3 5. 2 into 2 into 3 into 3 into 5. 2 pair, 3 pair, but 5 is not in pair. Since 5 is unpair, this 180 is not a perfect square. The number 5 is unpair. 5 is unpair. We should multiply this 180 by this unpaired number 5 to make it a perfect square. Then this 180 is multiplied by 5. If 180 is multiplied by 5, then 5 0 times is 0, 5 8 times is 40, 5 1 times 5 6 7 8 9, 900 is getting. Hence the required smallest square number is equal to this 900. This 900 is the answer. See, yarni ko gyan tare ko. Okay, let's study now question number 10. Find the smallest square number that is divisible by each of the numbers 8, 15 and 20. This question number 10 is same as question number 9. So you practice this question number 10. Now exercise 6.3 is over. So for today, let's stop here. Okay, all of you, thank you.